When one thinks of the word virus, many things might initially come to mind. I know that for me, as a biology major and as a science teacher, the first things that came to mind were different types of viruses. We are in the midst of cold and flu season, with COVID obviously still a daily threat, which got me thinking about other things that we get vaccinated for. So I could add to this list: measles, mumps, and chickenpox viruses. And upon further reflection, I wanted to add more to this list. I was thinking back on my time as a graduate student at Appalachian State University, and I can add even more viruses to this list based upon my own research there, which include herpes simplex, poliovirus, and vesicular stomatitis virus. As I was generating this list, I was realizing that there were a lot of emotions that were coming forth, and a lot of those were negative. So further associations I could make with this word included the words fear, anxiety, resignation, worry, frustration, and even anger. I began to reflect on why I was experiencing these emotions. Why were they all negative? And I realized that it had a lot to do with the COVID-19 pandemic, of which we're about 4 years out from the start of the beginning of that. Okay. So as I was reflecting, I was realizing that I didn't always feel this way about viruses. At one point in time, what I was actually feeling in response to this word was hope. And you may be wondering why that is. Well, with my research at Appalachian State and in the context of cancer, this was an emotion that became a real possibility for me. And this is because that there are 3 traditional treatment options available for cancer patients. Of course, this list is not an exhaustive list. There are a wide variety of treatment options now available, but the traditional 3 have been surgery, radiation, and chemotherapy for decades. However, as patients experience something called metastasis, the success rates of these treatments diminishes significantly. Metastasis is described as this process by which cancer cells from the primary tumor, which you can see in the upper left-hand corner, develop the ability to migrate away from that tumor, enter a blood vessel or a lymphatic vessel, and then exit at a secondary location where they can then form an additional tumor. And again, this process not only severely decreases or negatively impacts patient prognosis, but it impacts the success rates of these particular treatment options, which has led scientists to exploring new avenues of cancer treatments. Which leads me back to our original word, viruses. How can viruses be used to treat cancer? Well, oncolytic viruses have been studied for decades for their preferential ability to infect and kill cancer cells while sparing the normal healthy cells. However, I was primarily interested in how viruses impacted other cells found within the tumor microenvironment. Because contrary to popular belief, tumors are not primarily composed of cancer cells, or solely composed of cancer cells, I should say. Rather, it is a metropolis of cell types. A lot of those additional cell types include immune cells from the patient themselves. And I was primarily interested in the presence of these myeloid cells and the virus's impact on those particular immune cells. The myeloid cells of interest to me were macrophages. Again, these are immune cells. They can be broadly categorized into 2 groups. It's a bit of an overgeneralization, but for the purposes of today, it will work. Okay? We have our M1 macrophages on the left-hand side. M1 macrophages are more pro-inflammatory macrophages that often arise in response to viral or bacterial infections. And these natural capabilities against bacteria and viruses in particular naturally lend themselves towards being more anti-tumor. Our M2 macrophages, on the other hand, are more anti-inflammatory macrophages that often arise in response to tissue repair or reestablishing a blood supply at the site of an injury. And unfortunately, these natural capabilities lend themselves towards being more pro-tumor inactivity. So patients who have solid tumors, the higher the percentage of M2 macrophages that someone sees within these particular patients, the worse off their prognosis generally is. So again, interested in seeing how oncolytic viruses could impact these 2 cell types that have very different impacts upon cancer cells. Okay. The virus that I was especially interested in is called vesicular stomatitis virus. If you hang around horses more than the average person, that may be a familiar virus to you. It is a virus that naturally infects hoofed animals such as horses, cattle, and pigs, and even some insects. And I looked at 2 different strains. I looked at the wild type version of the virus, which is the version of the virus most commonly found in nature, and a mutant form of the virus called M51R. And this mutant version, because of this mutation to its genome, is less virulent than its wild type counterpart. And then I looked at both of these viruses under 2 multiplicities of infections, or MOI. MOI refers to the ratio of virions to cell. So MOI of 1 is 1 virus particle per cell, and MOI of 10 is 10 virus particles per cell. So I looked at both of these strains under both of these MOIs and exposed M1 and M2 macrophages to these viruses. And in particular, I was interested in seeing the impact on cell viability. Are these viruses capable of killing these M1 and M2 macrophages? And if so, to what degree? So this is looking at the M1 macrophages. You can see on the x-axis, we have the control, we have the wild type virus at MOI of 1 in 10, and then the mutant virus at MOI of 1 in 10. And again, looking at cell viability. So the ability to survive this particular viral exposure. And as you can see, in general, these M1 macrophages do not experience a significant decrease in cell viability, meaning that VSV is sparing these anti-tumor M1 macrophages. Our M2 macrophages, though, tell us a very different story. Upon exposure to both the wild type and the M51R virus, we see a significant decrease in cell viability with, again, both strains and both MOIs. And so this is telling us that VSV is killing the pro-tumor M2 macrophages. Okay, so this is just the tip of the iceberg. Research continued to see what the impacts were on the surviving cells, and those also seem to have positive implications for cancer patients. So hopefully this provides a little bit of context for why I was experiencing some hope as I was working with viruses. Of course, again, my opinion has changed a little bit over time with the COVID-19 pandemic, but again, some of that research did inspire some positive emotions in me. But of course, we have to recognize that research is ongoing with this topic. My research in particular was focused on macrophages solely in culture dishes. So they were the only cell type being grown within that culture dish, and they were being exposed to the virus. This is a very different environment compared to that of a cancer patient and a tumor itself. Okay, so while this has incredibly positive implications, and it is just the beginning of the research process, we do have to recognize that there is still a ways to go, at least concerning vesicular stomatitis virus. As you can imagine, there are numerous challenges to finding support for using viruses to treat cancer patients, several of which are listed there on the right. But the one that I want to primarily focus on is public opinion. If you recall from the start of the presentation, I listed several viruses that came to mind as I thought of the word virus. And as you were looking at that list, you may have noticed that some of these viruses can have severe negative side effects for a patient or can even cause death. Poliovirus, for example, and of course COVID-19 being at the top of my personal list. I also want to remind you of the negative emotions that I experienced as I was reflecting upon this word. And I can only imagine that I am not the only person who walked away from the pandemic, or 4 years post the start of the pandemic, experiencing some of these negative emotions around this entity. So there is quite a bit to overcome in terms of educating the public or promoting this idea of using viruses to treat cancer and recognizing it as an idea that needs further research and further attention. But clarifying any misunderstandings and educating the public is going to require obviously ongoing public education and very clear communication about the possible benefits and the safety surrounding oncolytic viruses. But while more research is necessary and is ongoing, especially for vesicular stomatitis virus, all of this research that we have so far certainly challenges our current understanding of these deadly pathogens. And hopefully one day, perhaps, viruses can be referred to as cancer's unexpected enemy. Thank you.